Welcome to The Explainer. I'm so glad you're joining us. Look, today we're unpacking the absolute biggest AI breakthroughs of the week, and honestly, perhaps even more importantly, the hard economic realities of actually deploying them. So let's just dive right in.
We've got a lot of ground to cover today. We're going from cracking image composition and Microsoft's transparent training right into the open model surge, local execution, and finally, the gritty economics of AI agents.
Starting off with Section 1, cracking image composition, which, believe it or not, was actually considered a partially AGI hard problem just 4 short years ago.
Just look at the sheer level of control in this ZestLab ad. This was generated by the newly launched Revi 2.0 and Ideogram 4.0 models, and man, it brilliantly illustrates how bounding boxes and layout prompting are just completely changing the game. I mean, creators now have unprecedented control over exactly where objects and text belong within the frame. You aren't just rolling the dice with a prompt anymore, hoping for the best. You're actually mapping out the exact structure of the image before the model even starts generating. It's wild.
But we have to look at where these models actually stand right now. Up on the Arena leaderboard, Revive 2.0 has shot straight up to rank number 2, and Ideogram 4.0, it's claiming the top spot for open models. These are absolutely massive achievements for spatial understanding, but as you can see, the data shows GPT Image 2 still retains the overall crown. So the gap is definitely closing, but the king hasn't been dethroned just yet.
So how exactly did they crack this spatial problem? Well, AI researcher Tae-Sung Park points out something really fascinating here. By reducing images into these bounding box layouts, researchers have effectively turned image composition into a next token prediction problem. It's exactly like how a text AI guesses the next word in a sentence. This reframing is a real game changer because it provides a massive compute boost for these notoriously intense diffusion models.
Moving to Section 2, Microsoft's transparent training. How are these incredible frontier models actually being built from the ground up? Let's take a look.
Microsoft honestly surprised the entire industry this week by dropping a highly transparent 109-page report for their new model, MAI Thinking 1, and the performance numbers? They're staggering. We're talking 97% on the AIME 2025 math benchmark and 53% on SW Bench Pro for coding. It even beats Sonnet 4.6 in blind side-by-sides. But here's the truly crucial point. It's all about how it was built. This model was literally hill climbed from scratch using zero synthetic data and, get this, zero prior model distillation. That means all of its reasoning and agentic behaviors were learned entirely in post-training, without leaning on the outputs of any older models. That is a huge flex.
And they didn't stop at just sharing those benchmark results. Giving us a really rare peek behind the curtain, Microsoft revealed their exact private negative log likelihood, or NLL, training mixture. Look at this breakdown. It is heavily weighted with 50% code and 17.5% each for STEM and math data. Basically, this confirms a growing industry suspicion. If you want your model to reason well, you have to feed it an absolute mountain of code and structured logic.
So what's the business strategy here? Well, Microsoft is actively leveraging this highly transparent stack for enterprise customization, in a process they're calling frontier tuning. They claim that by using reinforcement learning environments adapted to specific enterprise workflows, these MAI-tuned models can hit GPT 5.4 level quality on specific tasks. But here is the kicker. They do it while being up to 10 times more efficient. Let that sink in. That is a massive reduction in compute costs for businesses.
That brings us to Section 3, the open model surge. Because while Microsoft pushes frontier enterprise models from the top down, we're simultaneously seeing a massive surge in open weight alternatives, shaking things up from the bottom up. Take a look at this absolute breakthrough from Google DeepMind. They just released Gemma 412b, which is an open weight model with a completely novel architecture. It uses this encoder-free multimodal design. Now, what that actually means in plain English is that it elegantly collapses those usual clunky modality encoders right into the large language model backbone. So it can take raw audio and project it directly into the text token space. It is just incredibly streamlined.
And the open source community, they are making massive strides in latency too. Over in the open audio space, the new MESO 1 8 billion parameter text-to-speech model just launched. It features one-shot voice cloning and an ultra-low latency of just 110 milliseconds. Guys, 110 milliseconds. At that speed, AI voice generation is effectively indistinguishable from actual human conversational timing.
Now you might be wondering, why does all of this open model efficiency actually matter? Well, it all comes down to one crucial threshold: 8 gigabytes. Thanks to some blazing fast updates from community tooling, heavily quantized versions of these incredibly powerful open models, like Gemma 4, can now run locally on standard consumer machines with as little as 8 gigabytes of RAM. Literally, the barrier to entry for highly capable AI is just completely plummeted.
Section 4, Local Execution and Hardware. This newfound accessibility is exactly what's driving the industry's massive push toward edge AI and local execution.
We are seeing this physical hardware shift perfectly illustrated by Microsoft's new Surface Laptop Ultra. I mean, just look at these specs. We're talking about a consumer laptop packing up to 1 petaflop of AI compute and 128 gigabytes of unified memory, alongside a dedicated RTX GPU. Basically, hardware manufacturers are anticipating a world where you don't even send your data to the cloud anymore. Instead, you're running these highly capable, optimized open models entirely on your own local device. It's a huge shift.
Finally, Section 5, the economics of agents. Because when we move from running local models to executing autonomous multi-agent systems, the economic realities get incredibly harsh.
As companies try to build out these agentic workflows, it's sparked a really fierce debate over something called model routing. On one side, you have experts arguing that routing is an absolute inevitable necessity. The idea is you dynamically pass simpler tasks to cheaper models because, let's face it, token budgets are a massive operational expense right now. But on the flip side, critics are literally calling these routing products snake oil. They're arguing that a giant frontier model is actually cheaper in the long run because it gets the answer right the first time, which avoids costly retries. They say dynamic routing just destabilizes the whole system.
But honestly, whichever side of the debate you fall on, the enterprise constraints driving it are becoming very, very real. Recent reports show companies like Uber are starting to enforce hard cost ceilings. They're capping coding agent spend at $1,500 a month, per employee, per tool. And it makes total sense. When a single autonomous coding agent can run up a massive API bill just by looping through thousands of tokens in minutes, cost control suddenly becomes the single most important feature of any AI system.
And right here is the concrete data, proving exactly why routing and open models matter so much in solving this economic crunch. The AI legal company Harvey ran a benchmark test across 100 tasks, and what they found is fascinating. A hybrid agent, which used a cheaper GLM 5.1 model as the main worker, and the expensive Opus 4.7 model just as an advisor, actually beat a pure Opus system in overall performance. It hit an 18% pass rate compared to just 14%. But you have to look at the cost. The hybrid approach slashed the price from $954 down to just $368. That is better performance at less than half the cost. No wonder everyone is talking about this.
Which leaves us with a critical and honestly defining question to consider as we wrap up today's explainer. As these capabilities continue to rise astronomically, but enterprise budgets rapidly tighten, will the future of AI truly be ruled by monolithic, expensive frontier giants? Or will the real winners be the highly optimized, cost-saving hybrid routers that are seamlessly blending open and closed models behind the scenes? It's definitely a fascinating space to watch, and I really encourage you to think about how your own workflows might adapt to this new reality. Thank you so much for learning with me today, and I'll catch you in the next explainer.